Alright, so, human strength. We're going to talk about what propels you forward. We talked about what slows you down, so I'm going to talk about what is propelling you forward on road bikes. Well, on any bike, but, on road bikes. So, what's propelling you forward is your human strength. Okay, human strength is made up of muscles. Okay, those muscles are made up of strands. Those muscle strands, which is a set number of strands that can never change, are made up of fibers, and there is also a set number of fibers. You do not get more muscle fibers, ever. Those do not increase, okay? But you do get more muscle mass, and mass is always in width of the muscle. Okay, so Pepsi here has some leg muscle. Okay, and her leg muscle can get wider. Okay, and each of the muscle fibers gets wider in kind of a ring formation, and that's more muscle mass, and that does include more muscle cells. All right, so each muscle cell has a strength to weight ratio of being able to move between 800 and 1,500 times its own weight. The problem is you have a lot of dead weight, and the other problem is that's direct weight movement. So when you move your arm with your bicep isn't moving very far. It's only moving a couple of inches. And so in order to get your arm to have a decent range of motion, it has to move. Your muscle has to move against leverage. So that leverage significantly reduces the strength to weight ratio of the muscle. Plus, don't overestimate the weight of your muscle. Your biceps are a quarter pound to maybe 3/4 of a pound. Okay, so they should have 800 pounds of strength divided by the the distance that your hand has to go. Okay, versus the inches the 2 inches or so that your arm, that your bicep moves. Your arm moves like 18 inches or so, which means you're talking about a 1 to 5, 1 to 6 ratio, which is pretty bad. All right, that means you have to divide that weight limit by about 6 or so. So let's say my bicep can move 800 pounds. My hand can only lift a sixth of that, so maybe 120 pounds. Except there's still some reduction in that because a lot of the weight, when you measure a muscle's weight, you're actually measuring a lot of blood. You have to reduce the weight by including only muscle cells. And to be honest, to God, dried out muscle with no water in it and no blood in it doesn't weigh very much. In fact, your bicep might weigh less than a quarter pound, which means really it's 200 pounds, and then 200 pounds divided by 6, which is 50, 60 pounds, which makes sense because that's about the maximum that I can curl, like 50, 60 pounds. These really big muscle guys have really large muscles, so their strength to weight hasn't really increased. They just have more muscle cells. Your strength to weight never increases. You just have more muscle cells for how big your body is. Okay? Those muscle cells don't actually really increase in strength. It's muscles that increase in strength. And they increase in strength by adding on muscle cells. That's important to know because in endurance road cycling, you don't increase in muscle mass to get faster. You increase in endurance, which means your heart and lungs pump blood more efficiently throughout your body. And you reduce your calorie output from, we'll talk about calories later. But you really increase in efficiency quite a bit. Your muscles retain their strength, and they retain their maximum strength for their volume. The problem with that is that a lot of that is genetic, and that is why genetics matter so much, and I'll talk more specifically about them someday in the future. But genetics matter a lot in bicycling. And when we talk about elite riders, we shouldn't talk about them because their genetics are 10 out of 10 in every category, which is cellular, muscular, and musculoskeletal. Okay, so their cellular genetics, for example, means that their muscle cells are actually stronger for their weight than yours are. Okay, so their muscle cells have a little bit more mitochondria in them, and it is only it's about less than 1% of extra mitochondria. All right, but with that, you're going to see significant improvements. Seriously significant. This was in a movie once, actually. You can look this up, though. You're going to see huge improvements in physical strength and stamina and all this. So, be discouraged by that fact, because you don't want to be encouraged by how strong you think you are when your mitochondria has a set limit, and you'll basically never be elite. Okay. Being that as it may, you still have a chance, and I'm going to eventually explain why you still have a chance. So, when cycling, when going forward, the only thing pushing those pedals is your feet. Okay? And your feet are connected to muscles. Okay? And those muscles are what push your feet down. Alright? That pushes you forward. That is the force you have. That's it. It's working about 6, 7 forces against you. Okay? The biggest two being inertia and air resistance. So, you're looking at a lot of, my black cat is throwing my camera off. You're looking at some serious differences in genetics, because if somebody has more mitochondria, that's cellular, and you cannot change that. There's nothing you can do about that. If they have that advantage, then they have that advantage and you do not. Whatever you do, your muscle cells can't produce the same amount of effort. They can't recover as fast, and they can't eat as much oxygen at a time, because that's what mitochondria do. And your muscle cells have way more mitochondria than your blood cells do. They have way more mitochondria than your white cells and your blood do, and your skin cells and whatnot else. Okay, they have more mitochondria than that, so that they can eat, so that they can burn energy faster. You have 3 types of muscle fibers, okay, which contain the 3 different types of muscle cells. Okay, and that is endurance, which is type 1, minute muscle or in between muscle, which is type 2A, or it's also called anaerobic muscle, and then type 2B, which is neuromuscular muscle or sprint muscle. Okay, now the difference between type 2A and type 2B, the difference between endurance type 1 and type 2A is somewhat mediocre. But the difference between endurance and sprint is outright this. Endurance muscle uses oxygen. Endurance muscle uses oxygen that you breathe into your body, and it uses oxygen at the same rate that you breathe in.